Hello everyone. In this lecture, we will see what is transfer function. So in any system, first the system parameters have to be designed and their values should be selected as per the requirement. And the input is selected next to see the performance of the designed system, which is shown in this figure. That is, first the selection of system parameters is done. After that, we'll give the input for these system parameters to get the desired output. So output is equal to input into the effect of the system parameters. So we can find out the effect of the system parameters as output by input. Now, this effect of the system parameters, role of the system parameters in the performance of the system, it can be expressed as the ratio of the output to the input, which we have shown here. So mathematically, such a function explaining the effect of the system parameters on input to produce the output, it is called as the transfer function. And due to the own characteristics of the system parameters, the input gets transferred onto the output once the applied to the system. And this is the concept of transfer function. So transfer function, it can be defined as a ratio of the Laplace transform of the output signal to the Laplace transform of the input signal, assuming all the initial conditions to be 0. So here this is the condition to find out the Laplace transform. Okay, sorry, not Laplace transform, transfer function. That is, all the initial conditions should be assumed to be 0. So suppose if we are given a system where we are applying the input as R of t and the output will be C of t. So if we take the Laplace of this, we will get it as input R of t will become R of s and C of t will become C of s, whereas G of t will become G of s. So G of s, this G of s is nothing but the transfer function of the system, and it can be mathematically represented as what? Laplace transform of the output to the Laplace transform of the input. How? When all the initial conditions are assumed to be 0. So G of s is equal to C of s divided by R of s when 0 initial conditions are assumed. So this is the definition of the transfer function. Now let's see the properties of the transfer function. So the first property of the transfer function is 0 initial condition, as we have seen in the definition that it can be obtained when all the initial conditions are assumed to be 0. And it is same as the Laplace transform of its impulse response. And here the differential equations can be obtained when we replace the s by d by dt. Okay. So next is poles and zeros. So it helps in determining the important information about the system, that is the poles, zeros and characteristic equation of the system. And also here the stability of the system can be known once the location of the poles and zeros is known. And the last one is this transfer function, it can be applied only to the linear systems. It cannot be applied to the non-linear systems. Next comes the advantages. So advantages here are, it is a mathematical model and the gain of the system. That is, it gives the mechanical models of all the system components and hence the overall system. And the individual analysis of the various components, it is also possible by the transfer function approach. And when you replace s by d by dt in the transfer function, then you will get the differential equation for the system. You can obtain the poles and zeros from the transfer function. Once these poles and zeros are obtained, you can easily know whether the system is stable or unstable. And here the impulse response of the system can be obtained, because here we have seen that the Laplace transform is same as that of the impulse response. Then comes the disadvantages. Here one of the main disadvantages of the transfer function is it is applicable only to linear systems. and it is not applicable if the initial conditions cannot be neglected. That is, when you take the Laplace transform of the system equations, you assume here all the initial conditions to be zero. Okay, so here you cannot neglect the initial conditions. That is one of the disadvantage of the transfer function. And last is, it will not give any information about the actual structure of the physical system. So these are the three disadvantages of the transfer function. And here, this is the Laplace transform. This table is about the Laplace transform of the electrical network. So when you have a resistance in time domain, you will write the voltage as I of t into R, whereas in Laplace domain, you can write it as I of s into R. Okay, and this is the Laplace domain behavior, that is R. Inductance, you can write it as L into di by dt, whereas in Laplace domain it is written as SL into I of S. Similarly here, the Laplace domain behavior is SL. The next is capacitance C. It is given by 1 over C integration I of t dt in time domain. That is the voltage of the capacitance. In Laplace domain, you can write it as 1 over SC into I of S. And similarly here the Laplace domain behavior will be this one, that is 1 by SC.